Alright, so do you guys see my screen? Am I all good with the audio as well? All good with my audio? Okay, fine. Okay, so before I start with the class, I just want to tell you I have added an additional block just to do a basic WLC or a wireless WLC setup. Okay, we cannot do a full-fledged lab because we don't get the access point inside GNS, so we will not be able to test it. But I can show you how does WLC dashboard looks like, where are the access point getting discovered, what are the different features of WLC. Okay, so basically, if you remember, this block may not be present in your GNS topology because I just added it today. Okay, it was quite simple. It was not very difficult process. I had to go to Cisco website, Cisco software uh, website. So let me just write it here: software.cisco.com. Okay, I have the template which I normally use. So it was a VLC GNS file, and I just downloaded that particular package. Okay, this is the package 8.3.150. It's like 356 MB. I will provide you the link to this if in case you wanna deploy it on your GNS, you can take this from me. It's a ISO file which is like 350 MB size. Okay, and once you know the process, you know how do we deploy. If I have a, let me show you that quickly. Okay, so let me click on appliance, import appliance. So it will ask me for the download of appliance. So I'll click here, open, next, next, next. Okay, so basically my template is supporting just three of them, but what I downloaded is the latest one, that is 3.150. So I just clicked on new version. I created 150 dot something. Okay, I don't want to do that because I already have. Okay, but anyway, just let me show it. Okay, I'll click on OK or new, and you see that it's going to automatically detect the new one. In case if it doesn't detect, don't worry, you can click on this ISO and you can click on import. Okay, so the moment you click on import, you can just browse through that particular ISO file and you can hit open. So once you hit open, that's getting imported within your GNS. Very simple task. Okay, as a IT engineer, you must know how do you deal with GNS. So don't always be very dependent on our lab trainer for each and everything. Okay, you need to know, because in future might be you're studying for a firewall, or might be you're studying for SD-WAN. So it doesn't look good that you do not know to import a basic uh, instance. Okay, but yes, those who are dependent on our lab trainer, he will work it on and he will give the way he used to give every time. But what my suggestion is that be little bit technical when it comes to doing all those things, because it's after all going to help you. Okay, so once I do that, this is the one which is installed. I'm going to click next and yes. Okay, next, next, finish. So it says that it's been installed, and if I go here, so this is what I installed in the morning and this is what I just installed right now in front of you. I can just drag it and I can get it here. So this is my WLC. Okay, wireless LAN controller. You just need to connect a switch the way I have shown here. So let me show you the physical representation. So this is my WLC controller, this is my switch, this is my computer where I have Firefox to take the GUI of this wireless controller. So where do you think we connect access point? So access point is connected over on this switches, but unfortunately we don't have anything for access point, so I cannot show you the wireless connectivity and the access point getting discovered within WLC. Okay, but yes, I'll show you WLC from the WLC point of view. What are different options? Okay, so let's go back. Let me just delete this because I don't need two instances. One instance is good enough. I'll show you how do we deploy all those things. But before that, I have a short topic, short theoretical topic, and all the recaps what we have done previously. So if you remember, in the wireless topic, um, on the previous day, we covered topics like wired versus wireless. We covered topic like basic service set, also known as BSS. We also covered topic like radio frequency, RF in short form. So you know the two widely used wireless. So it's 2.4 gigahertz and 5 gigahertz. You also know what is wireless band and channels. Channels are nothing but what are the best channels for 2.4? It's 1, 6, 11. Whereas for 5, all the channels are best because they don't overlap. What else did we cover? We covered about encryption. So yes, so these were few topics which we covered day number 1. So what do we have today? So the topic is quite less for the day. Okay, today we are just going to see like 2 to 3 different uh, topics. Like we have WLC deployment models. We have something called as wireless LAN 802.11 service set, and we have a basic GNS lab. Okay, where I'll demonstrate the overview of WLC, the controller. That's all. That will end your the wireless syllabus. Okay, so let's check it out for the topic number 1 for the day. So let's say wireless LAN 802.11 service set. So what do you understand by wireless LAN 802.11 service set? Okay, so I told you this is an access point. Okay, so they emit a 360-degree signals. Okay, so collectively we call it as BSS, basic service set. The access point with a MAC address binding is referred as BSSID. And what do you understand by just SSID? SSID is just a human friendly name. Okay, so let's say if I have a client, you have some SSID for management, you have SSID for guest visitors, you have SSID for kids, so might be many other SSID. So that's just a human friendly name. So might be your kids is being allowed to access only this SSID, and you have set some username and password, so he can only connect to that SSID. The others he will not. Okay, so this was just the overview of what we discussed. So today I'm going to describe the different service set from uh, the point the access point is placed, the usage of access point. Okay, so the first one here is called as IBSS, which refers to independent basic service set. So you know what is BSS. Now what do you understand by independent basic service set? Okay, it's a condition when two or more wireless devices connected directly without an access point. Why do you think we connect to three different users? Let's say laptop number 1, laptop number 2, 3, and 4. So why do you think use a we use such kind of setup where two or more wireless devices are connected directly without any access point? So basically what you do is you will set up some network here, you will set up some internal network over here. Similar way you will set up some network here, and you form a network and you just connect between them. Best example like your share it, right? Application like share it. Do you think you always need an access point between two share it? No. You open up that share it application, you will set up some local network, and you will ask your friend to join that network, and then you can exchange the file, right? So those who doesn't know what is share it, it's a Android file transfer application. Okay, there are a couple of alternatives, something called as Xander. There are a lot of alternatives for share it. There's one more which is very good and very fast. Okay, this is one example. Second example would be, have you ever played a LAN game where we create a network and we share it with our friends and we all connect and play Counter Strike or any LAN games, right? We don't need an access point, but we still can create something called as a group and we can connect and we can play around, right? So that is called as independent basic service set, and something where you just have your wireless capable device which you can connect to each other without the need of access point. Okay, the popular usage is transfer file between laptop smartphone without connecting to an AP. Okay. Okay, now there's something called as distribution system, also called as DS. One second. Okay, so what is distribution system? So let's say I have a BSS in the sense basic service set, where I have an access point and I have different hosts or users connected to the access point. Now, who gives an upstream data to access point? What do you understand by upstream? The unit which is giving the input to access point, because access point is giving the output, right, with the help of SSID. It's just giving a provision of connecting to network. But who is that particular person who is giving the input, or the VLAN? In short form, I can say that VLAN. It's nothing but your dedicated switch, and the switch might be connected to the network administrator laptop. Might be your network administrator is controlling the switch, is configuring the required access layer port, right? So we call this portion as DS. This is a wired medium. So your switch to your access point will be connected over wired medium. It's a distribution system. We call it as distribution system. Okay, one second. So what happens here is this wired connection or this wired cable, I can say that the L2 Ethernet frames are being carried, right? Because it's a connecting to switch, and switch carries the Ethernet frames. So the switch which connects to access point, we can configure it on single static VLAN itself. Most of the time the access point works on access layer, but yes, there are some access point which can also work in trunk. Okay, so let's say there are some access point which needs two different VLAN to be broadcasted. Might be one is dedicated for data, and the second one is might be dedicated for voice or for some other purpose like RFID. I told you what is RFID, right? So this is a scenario when you need trunk connectivity between your switch and your access point. Okay, when you need two different network, most of the time it the access point will work on access layer, a single VLAN. Okay. Okay, so what else that DS can provide? So DS can also provide the input to two different networks, something which I already told you just now. So let's say I have a switch and we have a AP connected here, okay, within this BSS. So let's say I have my clients over here. Now let's say this particular AP which is to be on trunk, might be because the host is from management team and this host is from sales team, so they have two different network, right? So I say that I want 10 and 20. So this switch will be connected might be to another gateway where I have VLAN 10 configured, and I have another gateway where I have VLAN 20 configured. Okay, and this switch act as the DHCP. So in this case over here, I'll make use of trunk. So this trunk will support two VLANs 10 and 20. So this management guy can now access whatever file TFTP server is this. Okay, similar way, if this is a salesperson, now he can access this particular server if is trying to access something. So this collectively is called as DS. Okay, so that's called as DS. Now important thing about ESS. What is ESS? It's called as extended service set. Okay, so what do we understand by BSS? BSS is something which use single access point. Remember that. Okay, BSS is something which use single access point. Now what is a drawback of having single access point? There are two drawbacks. One is from coverage point of view, because one access point kept at center, so your hosts are to be very nearby to the access point. Otherwise, if they move on, the connection will drop. The second drawback of using single AP is bandwidth, right? So all hosts dependent on single access point, so they are they might get interference issues. Might be the other users are downloading something, because of that the third user is facing some issue, slowness issue, or the user walks away, okay, opposite to access point. Might be his desk or seat is somewhere far away from the access point. So this also cause loss in the packet, right? So single AP is not a best solution, so we make use of multiple APs Okay, we make use of multiple APs to achieve a smoother wireless connection or wireless connectivity, and we call that concept as extended service set. So if I say that extended service set is one such scenario where you will see multiple APs are kept. Okay, and if I say multiple access point, now you might be wondering, how about SSID, or how about BSSID, right? So we will discuss the same thing now. So let's talk about ESS only. A simple option would be, let's say I have my DS, the distribution system. I have a switch over here, switch number 1. Let's say this is my whole together, the ESS, the extended service. And I told you there are now two access point. One is access point here, the second access point is over here. Now what about the BSS? So I can draw something like this. This is the BSS for 1, and the second BSS will also be overlapping something like this, which is important. Okay, so something like this portion of two BSS should overlap. That's a good thing. The reason is because the SSID can be same. Let's say I have a SSID called as MGMT. The same SSID I can also configure here, MGMT. So what happens is, if a user who is over here, who is connected to this SSID, if he walks towards to this direction, I don't want his signals to be dropped, or I don't want he getting connected to a new SSID, right? We are keeping a unique SSID or a common SSID in both the BSSI. Okay, what about the VLAN? So we can connect something like this. So I have a switch, I can lay two cables between switch and AP1, and another cable between switch and AP2. Okay, so this one will have its own BSS ID. So let's say the BSS ID is something XYZ, and over here the BSS ID is something ABC. Okay, so you see there are two different BSS ID. I told you BSS ID deals with machine understanding or machine learning. Okay, the for your convenience we make use of SSID, which is human friendly. So user don't need to be bothered about which BSS ID he is connected to. User will just connect to SSID, whichever SSID he is being asked, he will connect to that SSID. Let's say MGMT, he will be given some username and password, so he is happy with that. Might be if he happens to move from away from this access point, as soon as he reaches towards the second AP, now he will automatically get connected to the MGMT SSID without reconnection or without uh, failing from the network. Might be he was downloading a file when he was walking from this point to this point. Might be his file might get interrupted, right? That doesn't happen in this case, because in the backend is that BSS ID, which is machine understanding, and we don't need to know what is happening in the backend. So backend, the packet will do the necessary requirement so that user don't get interrupted. Okay, the whole approach now is called as ESS, extended service set. This is very important when, let's say, you have a conference meeting in very large hall or a large meeting room where you need to keep 3 to 4 access point, and if a user is walking from one access point to second access point, his network will break, right? So we will configure the same SSID on all the 4 access point. Okay, and if he's moving from one to second or second to third, his network will not drop. And the backend, that's the okay. So in the backend, it's the BSS ID which will deal with all the uh, packet flow and all. Okay, so this kind of shifting from one access point to another access point, we normally call it as jump. Okay, so we make use of the word called jump from one access point to another access point. We can also call this as roaming. Okay, now there is one more service set which is called as mesh basic service set, MBSS. Okay, MBSS. Now this is very interesting concept. Okay, so let's say if I have access point, access point, access point, and access point. Okay, so basically these access point are capable of having multiple radios. I'll tell you why we need multiple radios. So basically what happens here is we will have one more access point which will act as the root AP. In short form, I can write it as RAP, and this will be connected to the switch, the network device. Now what about the other devices? They are all connected over the radio, or the radio. Okay, so basically what happens is this access point, if it has a free radio antenna, it will make use of one radio frequency of one access point to other access point. Similar way, let's say the other radio of this will be used for the data connection or user connection. Now how about this access point getting connected to another access point? So this will have multiple radios, I told you. So this will be connected over on another radio. So basically I can draw something like this. So these access points comes with various radios, and one radio will act as backhaul for the other access point, or they form a mesh network. Okay, mesh network is something where each and every point will be connected. Okay, so you have connection between this and this, you have between this, because the dedicated radio will form connectivity between the two access point. And who is who is that access point which is forming a uplink with the switch? That's called as root AP, and we call these all other APs as MAP, which is nothing but mesh AP. Okay, mesh AP and root AP. Okay, now regarding to access point modes. Okay, so why do we need to have multiple access point mode? So let's say repeater is one such access point mode. There's something called as work group bridge. Okay, and there's something called as outdoor bridge. So let's discuss the first one, that is repeater. So in the case of repeater, let's say if I have access point, the access point is connected to an host. Okay, let's say PC1, and the second PC is quite far away now. So the signal is not really very powerful to this PC2. So what I would do is I would keep a repeater somewhere here. Okay, I would keep or deploy a repeater. Now what this repeater does is, this repeater is going to transmit the signal to the PC2. Okay, we call it as, it's going to receive the signal and retransmit. So it just cannot be placed wherever you want. Okay, so there is some logic behind that. So let's say if this is my BSS, okay, so repeater will be placed within that BSS, with the BSS between AP and the repeater. And now make sure the PC2 somewhere it falls within the BSS of repeater. So if I draw another circle, okay, from the repeater point of view, now then that's how the PC2 will have the boosted or the retransmission signal. Okay, so repeater and the AP should fall under the same the BSS. They cannot be far or quite far away. Okay, so that was regards to repeater. So what is work group bridge? Okay, so basically there are two types of work group bridge. One is called as UWGB, which is written as Universal Work Group Bridge, and the second one is WGB, Work Group Bridge. Okay, so this is a scenario. This is a scenario where your devices don't have the radio capabilities. For example, printer, right? Let's say it doesn't have a wireless radios, or let's say a computer. So if you know those the old days computers with the CPU and monitors, they didn't have any wireless. We used to plug those wireless kind of USB so that we could connect it with wireless modems or access point, right? The other examples would be like point of sale or old printers, right, which doesn't have radios, no radios. Now in this case, how do we form the connection, the wireless connectivity? So let's say this is my BSS. I have my access point. Access point is connected to the wireless host. That's all good. But on the other side, I have a printer. Okay, and the printer don't have any radio within it. So in this case, what we do is we deploy something called as work group bridge. Okay, so let's say I deploy this particular hardware. So this hardware will be connected over on wired with respective to printer, and on the other side this will be connected over on wireless to access point. Okay, so that's how we will achieve the requirement. Now there are two types I told you. One is universal work group and work group bridge. So in the case of universal, it's going to support just a single wired client. Okay, so let me write over here universal. It's going to support single wired client, and it's based out of the wireless standard. Whereas WGB, it's a Cisco proprietary. Okay, and it's a extension to 80.11. and it's going to support multiple wired client. Okay, so based on the wired connection, whether it's a single supported or multiple support, we have two ways to represent work group bridge. So I hope you got the scenario. When do we use work group bridge? It's a scenario when the end machine doesn't have a 802.11 support, it doesn't have a radio. In that case, we will make use of a wired connection. So let me see if I can show you how this work group bridge looked like. So you can see here the bridging happening here. You have computers. Computers don't come with any wireless adapters. So you have the bridge, and the bridge is connected on a wireless to the access point. Okay, that is what my whole point was about the work group bridge. And the two main thing, depending upon the features, are universal and the normal work group bridge. Okay, so the last topic is outdoor bridge. Now once again, depending upon the usage, we have two types here. One is called as point to point, and the second one is point to multi-point. Okay, so when do we need outdoor bridge? We need outdoor bridge when we need the wireless connectivity between two buildings, might be two cities. Okay, might be wireless connection between two buildings, right? Or between two cities. So is that really possible? Yes, it's possible. And we have point to point and point to multi point. So let's say I have AP. AP is connected okay, let's say it's a bridge unit, and then we have a building number 1, and on other side I have second building number 2, with similar kind of design, switch 1. Okay, so I can say so let's say I have a switch here, I have my AP here. Okay, now between these two buildings, I can have my outdoor bridge. Okay, bridge which is used between the building. Now this kind of approach is called as point to point, when it's between or directly between the two buildings. Now I guess you might be aware of point to multi point. Now that's a scenario where you're bridging more than two LAN. So this is one LAN unit. Similar way, this is another LAN unit. Now let's say I have building 1, the same approach, a bridging unit with switch, building 2 with similar switch, and let's say I have building 3. Okay, so I can form a wireless connection between these 3 buildings. So this is a LAN 1, LAN 2 and LAN 3, and this approach is called as point to multi-point. Okay, this is a outdoor bridging. We know what is bridging. Bridging is nothing but between a non-radio frequency unit. You are connecting, or you're making use of bridge hardware which can connect towards a wireless. So similar way, we have something called as outdoor bridging, which has two types: point to point and point to multi-point, and it's between two different buildings, or it can be used as two different cities also. Okay. Okay, fine. So let's talk about the lab now. So we are done with theoretical topics. Let's do the lab. So I already showed you how did I import this VLC. Let me show you how do we also configure this. Okay, so just follow my on screen. So let's say I bring this up and let me start this, because I have already finished the deployment of this. Okay, so I'll take the GUI from this, but the initial deployment I'll show it here, and once I've shown you the deployment, I'll delete this, and rest I'll take it once again over here. Okay, so over here I double click on that. So it will take some time. It's basically going to extract some backend files. So basically, like, you need 8 GB of free space on your hard disk so that this WLC get extracted and gets booted up. Okay, and then it will go for the initial configuration, like, do you need DHCP or static? Do you need STP configuration? Do you need some time zone configuration? So basically that kind of initial configuration. So I have already done or finished on my instance. So if I run now, it will directly take you to the prompt. It will not go towards those initial uh, configurations. So that's why I just thought of showing here. But yes, if it will take a lot of time, then I'll straight away go and show you the GUI interface. So let it happen. I'm just on mute. Okay. Okay. So instead of waiting for this to get loaded, let's keep it up. Let's keep it up. Okay. In parallelly, I'll just open up the dashboard and I'll just walk through those dashboard. Okay. So let's say the initial configuration has been taken care by you on this WLC connected to a switch, and over here I have the Mozilla browser. Okay. So let's put them on single network. So during installation, it's going to ask which network is your management going to be. So I had said it's going to be 192.168.10.10, and on the Mozilla browser as well I put something very similar network. I said it's 192.168.10.2. So let's open the Mozilla browser and let's try to access the dashboard. Okay, so it's 192.168.10.10. Okay, so this is how your wireless controller looks. This is possible when you have already finished the installation. So you have certain steps which you have to follow here. Okay, they are all documented. So I'll show you my PDF. So basically, what are those initial configuration that you need to take care? So let's say you will be asked whether, so you will be provided with this wizard, okay, on the WLC, and then you will be taken to the next step where you will define the system name, the administrative username, the password of the WLC. You will say if you need link aggregation or no. So basically we will keep it no. Okay, we will also configure the management interface on WLC. So this is my management. So this is the IP which I now took it with the help of HTTPS, and this is my GUI IP. Okay, so here is where this is the IP which I'm considering for the GUI access. I'll define my virtual gateway IP and multicast IP. Now, what are these two things? So basically, virtual gateway IP is nothing but it's used for mobility. Mobility in the sense DHCP relay, guest web authentication, VPN, and other features. So for these features, you need to have a virtual gateway set. Now, what is multicast IP? So your, let's say I have WLC connected to a switch and switch connected to APs. How do you think the communication between WLC and AP happens? They happen, or they communicate over on multicast. Okay. So what is the multicast IP for WLC and AP communication? So basically, we cannot use any such multicast IP which was, or which is scoped to be used by some other features. So we will make use of very safe multicast IP. So something like this. Basically, this network is used for administration purpose only. Okay, if you know, if let's say I used this was a HSRP multicast, right? So I cannot make use of as such any multicast which is also being used by some other services. So for this communication between WLC and AP, I'll make use of this network because that network basically is used for administration only. So these are the two fields which has to be set up during configurations: the virtual gateway and multicast. What else will it ask during the initial boot up? So it's going to ask you the RF group name. So you can give anything. You can give it as CCNP, whatever. Okay. And then it's going to ask you for SSID. So I'm going to set a SSID. And the rest of the things, like it's going to ask whether you have any DHCP bridging. So we can set it no, because normally in enterprise what we do is we have a switch is connected to WLC, right? So we don't set the DHCP over here. We don't set it. We keep another server where we configure DHCP. Okay, and we have all our access point and the other. So that's how we maintain. So basically, we don't need any kind of bridging. So we just turn it off. Okay, we don't need this, so we will leave it disabled. The next thing over here is it's going to ask if there is any static IP allow or not. So you can just set it up. By default it's going to set it up, so we'll keep it as it is. It's also going to ask you the radius server. Radius server is for authentication. If a user is a rightful user, right? So let's say I have WLC connected to switch connected to AP. I have a lot of users who are trying to access my AP. Now what AP does is AP will try to authenticate, or will see whether if that's a rightful user and if he's supposed to join this AP. If he is good, then yes, it will work. So basically the AAA feature has to be enabled inside your WLC. And finally you will set which country you belong to and what are the different standard that you wanna enable. Okay, so you can enable all these standards depending upon the radio frequency that your AP will help will support. Auto RF, you can say yes or no, best to leave enabled. You can configure NTP server, but which is not required for the lab purpose. At least we don't need NTP. Rest of the thing like system time, the date and hours, you can, yes, you have to set it. IPv6 you can just ignore for now, or you can skip for now, don't have to do anything. It's going to ask if everything is fine. So you are gonna write yes, everything is fine, and then it will go towards reboot. So once after the reboot, the first thing that you see is something like this. Okay, so this is what you get when your controller has successfully booted up. So if I open my controller, which was done with the initial configuration, I can show you I am right now on this prompt because I have completed my first one time wizard installation, right? So that's just a one time. And next, whenever I reboot, I straight away get this prompt of my username and password. So let's see if I do get that. Okay, so basically it's asking me for press any key. Not sure why is it not taking. Okay, anyway, I have the um screenshot of them. So basically this is what I get on my WLC CLI. Now here is the interesting fact. If you're good with the CLI commands, you can just input your username and password. You're gonna get this kind of prompt over here. You can put your all show commands, you can go to the config mode, do the changes. Okay, basically like how you have the Cisco boxes. But the interesting fact is, if you're not good with the CLI, you can take the graphical interface. You have done all the IP configuration, you have your IP ready with you, which is let's say 192.168.10.100. Just add HTTPS and take the graphical. So that's what I did. So if you see my lab, I have done all initial configuration, and let's say I don't want the CLI method. So I have my browser over here, and from browser I have taken the access to the controller. If you are good with CLI, go ahead with CLI. Now let's try to see the dashboard. So I am going to click on login. Just waiting for WLC to come. Okay, so basically these WLC, okay, fine. Looks like it's getting loaded up. Takes a lot of time for every instance to load. So this is how you get once they are successfully loaded up. Okay. Okay, so as a backup, I have captured the dashboard screenshot. Maybe I have to show you that because it's taking a lot of time for the boot up. Okay, so might be I have to show the dashboard. Might be in the next class. I have to keep it ready. But don't worry, I have the screenshot. Okay, so the moment you type the https, so yes, this is https, you are going to get this this kind of console or dashboard. You will input your username and password. This username and password is something which you already set during the boot up process. Okay, so somewhere over here you had set up some username and password. Once you're good with that, you will see the dashboard. This is the first page that you will see immediately once you are good with the authentication. So you will see what are the networks, you will see what are the different access point that's been connected with your WLC. Okay, so let's say I have a WLC which is connected to switch, and switch connected to multiple access point AP2, AP1. So these APs will be now listed over here as count number 2. So you can see the access point by usage. So which access point is consuming what kind of data. So this access point with this MAC address is consuming this much of data. The second access point is consuming so much of data. So you have your client, active client. So you have 2.45, you have the ROG devices APs, you have the interface. So this is the first dashboard, and you, on the left side you will see the network summary, the access point, the clients, the access point, client under ROG devices, the interfaces, the wireless dashboard like the performance, client performance. Also the dashboard is going to give something called as best practice. So this is very important. Okay, let's say you had missed out to configure some important thing during the boot up process. Okay, like NTP and all other authentication and all rest of things. So the best practice column is going to show you that you have a missing configuration for NTP, you have a missing configuration for AAA. So that's best practice. Okay, so under access point, when you click under access point, you're going to see what are the different access point that you are connected, what is the usage happening, what is the uptime. Uptime is nothing but how long these devices are being up and running, what are the channel numbers that they are being set. So you have 1 and 11 set, you have the coverage area, you have interfaces, the MAC address and all other things. So this is when you click over on the access point. Regarding the best practice which I was just talking about, okay, so when you click on best practice, it's going to show you the different columns and it's going to say what exactly is missing. So from infrastructure, you can just enable the other two, but it says that you have disabled the DHCP. It says that you have set the client exclusion, so you don't have any kind sorts of .1x features enabled, you don't have any CPU ACLs. Okay, so it's going to show you all the other parameters which as per the best practice should have been set, but it's not being set, the optimization. It also have something called as advance. Okay, over here on your WLC. So on the advanced mode, when you click on advanced mode, this is something which you will be seeing. Okay, so on this one dashboard, you will see a lot of detail. What is the management IP address, the software version, the field recovery image, the system name, uptime, system time, redundancy mode, the temperature, the different radio frequencies that's been enabled, the CPU usage, the individual CPU usage, the memory usage, the fan status. Okay, also you will see the rock summary, you will see the top WLANs, you will see the traps that's been detected. Okay, and you will see here the different features under monitoring: the access point, the clean aid, the statistic, the CDP, the ROG, the client, sleeping client, multicast, application, local profiling. So basically, WLC is used for like a controller or a centralized management tool, and your all access points will be connected to that. Okay, so unfortunately this is stuck still. Okay, so let me once close and restart. Let's give a last try. How many access point can be joined with Mobility Express WLC deployment? So it was like 100 APs. Okay. So while you travel in car, train, bus, it's the simple wireless technology which you connect with your ISP. Okay, so the binding is with your ISP, and when you move from one ISP to other ISP, or one uh, those telecommunication tower from other telecommunication tower, the ISPs have to be present. Let's say as soon as those towers are missing, you will lose your connection, and you will see sometimes you've been using another services with something called as R, or might be some kind of different notations of a different ISP. Okay, so basically in the backend they pay to the other service providers, and that's how you will be connected over on roaming and all other things. Okay, so the AP license we put within WLC. Okay, so within WLC we have to discover all the other APs. So there is a way we can discover the access point. So it's something like SNMP itself, where we can poll the device and we can discover them. So license will be put once again on the WLC page itself. So on the WLC page we have option for system. where you can place your license support. So if you want to check the logs of every users, what they access, URL, all those things, so you can make use of third party tool. Okay, or if your AAA server is capable enough, you can check there, or if you have a WLC from very good vendor. Okay, it depends on what your WLC is providing you. If you go with very simple Cisco's low cost WLC solution, then you will be not able to see each and every uh, minor details, like the URLs, all those things. Okay, you have different approach for doing this. There's a complete separate feature called as BYOD. We also have something called as MDM, mobile device management. So these are the feature with which we can see lot of details. Okay, with just WLC, it is just about seeing or seeing the AP utilization and all I can say the basic, the normal things. Okay, if you want to see very technical things like what URL, if you want to block something, then you need to get in few things within your network. So might be AAA. If you have a good AAA server, you can put a restriction. If you have a BYOD features or MDM features, you can set a restriction. So depending upon the third party, you can. But yes, if your mobility controller or if your WLC is very high end, then that particular dashboard itself is capable of giving you all the features. Okay, so this is really slow. Okay, I'm not sure, after completing so many CCNP class, you're once again asking something basic. So let's say this is a tower, okay, which is in some city, Delhi. You have some other tower which is in Kolkata, okay. So whatever wireless that we are connected, it's just between the user and the towers. But these towers at the in the back end, they are then cabled. They are cabled, and they lead to their nearby ISP provider. If it's a BSNL, so those are Indians might know what is BSNL. So they are a ISP or telecom provider who are into telecom and who are into ISP. So basically, they will be connected to their ISP office, and from ISP office, they will be connected to the other regional office, and from there, they will be connected to the submarine, and finally, they lead to the cable itself. So this connection is just between the users and the satellite provider. So whoever is the other different users here, they basically are connected over on the wireless with on a wireless on this kind of towers. So basically they can reach one another. Okay. So in the back end, it's once again the fibers which are used. Yes, Cisco ICE is once again a technology which we can use uh, for AAA as well, because AAA earlier we used to have ACS server. Now this has been taken down, and Cisco launched something called as Cisco ICE. This is very powerful, which can have AAA support, as well as it can support all other things like BYOD, MDM, and lot of other features, not just about this. You can also set some templates, lot of features which ICE can support. All right, guys, I better stop this console. Might be tomorrow when I start for a new topic. I'll also keep this powered on like 1 hour before the class. Okay. And yes, I told you in the beginning itself that try to do few technical things like whatever setup which I told you by yourself. Don't rely for each and everything for the lab trainer. Okay, so I can give you the image which you can deploy and you can practice it. But yes, I'll also ask the lab trainer to give you guys the updated topology, but you will have to wait for some time because the it depends on trainer when he fix and when he decode and he give you the GNS topology. Okay, so the best option would be just deploy yourself, because I have showed you the entire class was just showing you all these things. So I guess as a CCNP or CCI holders, it's something which you guys can take care. Okay, fine. So let's wind up for the day and we will meet up in the next class. So we are done with wireless topic. We will come up with something else. We have DMVPN, we have one SD-WAN class, we have uh, some minor topic QoS, we have IPv6. So these are few topics which we have, and also SNMP. So I think 5 to 6 7 classes back to back is all sufficient for us to wind up the whole CCNP portion. Okay, so let's meet up in the next class. I'll let you know which is the next topic. Okay, so have a good day, and see you soon, guys, in the next class. Okay, take care.